Hi, my name is Georgia Mori and I'm the group leader for Group 1. In this presentation, we will be presenting on the integrated waste management with a case study in Botanica City, Balik Pulau, Pulau Pinang. Botanica City is a high-cost residential area located along the banks of Sungai Air Putih in the district of Balik Pulau in the southwest region of Penang Island. As this is a landed properties, the waste generated will be collected and managed by the Penang Island City Council, or also known as MBPP. As for the waste generation in Malaysia, there are approximately 33,000 metric tons of waste generated per day, with a national average waste generation of 0.5 to 0.8 kg per person per day. Meanwhile, Penang has recorded a slightly higher waste generation at 0.9 to 1.1 kg per person per day, despite being one of the smallest states in the country. Unfortunately, the practice of recycling and separating waste at household level remains uncommon and very low in Malaysian households, despite of the implementation of the Separation at Source initiative under the Solid Waste and Public Cleansing Management Act 2007 that was launched in 2015 by the SW Corp. This figure shows the household waste composition in Malaysia reported by the National Solid Waste Management Department in 2013. As we can see from the figure, food waste accounts for the largest portion of the waste generated at 44.5%, followed by plastic at 13.2%, diapers 12.1%, which normally include disposable diapers for babies and elderly, as well as female sanitary pads, papers at 0.5% that include old newspaper, mixed papers, and cardboards, followed by garden waste, glass, textiles, metal, Tetra Pak, rubber, and so on. It is important to note that this waste composition may vary according to different seasons, geographical region, as well as the socio-economic status of a particular area. Next, the waste generation in Botanica City. We assume that there are a total of 400 landed housing units in this high-cost residential area with an average of 5 households in each housing unit. Therefore, the total waste generated will be 61,600 kg per month, considering the average waste generation is 1.1 kg per person per day. Assuming the separation at source is fully implemented where each household segregates and recycles their recyclable waste that include plastic, paper, glass, metal, and Tetra Pak, the total household recyclables will be 18,700 kg per month, and the remaining non-recyclable waste will be 42,900 kg per month, where this is the amount of waste that will be collected by the waste collector and transported to the MRF for further treatment and recovery processes prior to their final disposal at the Pulau Burong Sanitary Landfill. Thank you.
Hello everyone, my name is Huang Zixuan and my metro number is 149607. This is my part, collection and transport. There are two systems to collect rubbish in Penang State, which divide into primary collection system and the secondary collection system. The primary collection system is that the unaddressed solid waste is put in the personal dustbin by resident, and the other is that the solid waste is transported from the dustbin to refuse transfer stations and landfills. The distance from the final collection point of the waste is 35 kilometers before the waste being transported and unloaded at the waste treatment landfill. To move a compact truck with a load of 1 ton, the average fuel consumption is 10 liters per 15 kilometers. The Price of fuel is 1.8 ROGET per liter if the government provides 2 trucks for the area. And we can know the quantities of wastes that will be transported by waste treatment facility will be 42,900 kilograms per month. So the amount of waste we need progress every day is 15,900 divided 13 days. It is 1,313 kilograms per day. So only one trip a day to waste treatment facility, the daily fuel consumption of 2 trucks are 10 liters per 15 kilograms is 0.2 liter per kilogram. 0.2 multiply 35 kilometers multiply 2, it is 15 liters. The cost of fuel is 15 liters multiply 1.8. So finally, we can get the 25.2.
Hi, my name is Elisa Amira. I'm a second-year environmental technology student, and I will be talking about the treatment and recovery part of the municipal solid waste management process in Botanica CT in Balik Pulau Pinang. So firstly, why is waste treated? It is treated to reduce the impact on the environment as much as possible, and this can be done by transforming it physically, chemically, or biologically. So in our project, the waste is collected by the Pulau Pinang City Council and then taken to the thermal treatment plant, and then it will be taken to the Penang transfer station and finally to the Seberang Perai sanitary landfill. The treatment happens at the thermal treatment plant by way of incineration, which is a chemical transformation. What happens is the waste is burned, which can reduce the volume of waste to up to 90% and reduce the weight up to 75%. The waste that's burned is converted to ash, flue gas, and heat. The heat can be used to generate electricity. Here I've calculated the amount of waste reduced during the incineration. Given the formula and the waste reduction rate taken from a case study on solid waste management in Perai, also from the waste, the non-recyclable waste generated by Botanica CT, we find that the amount of waste after incineration has decreased a lot. As we can see, the waste has been reduced down to 10,596.3 kilograms a month, meaning that the waste reduced is 32,303.7 kilograms per month. This shows that there is a large decrease in the amount of waste disposed at the landfill.
Hello, I'm Lillian and I'm going to present on the disposal part. So in my part, there are a few things that I have determined, which is firstly the volume of waste deposited at landfill cell daily. Next is the area needed to accept and bury the waste daily and also annually. And lastly is the percentage of disposal. So, the material that left after the waste have undergone the recovery and treatment process will be sent to landfill for the final disposal. So the volume of waste deposited at landfill cell can be calculated using the equation mass flow from treatment to landfill divided by the density of waste. In this case, the density of waste is assumed to be 480 kg per meter cube. So the volume of waste deposited at landfill cell per day that I have calculated is 0.736 meter cube per day. Next, the area needed to accept and bury the waste can be calculated using the equation volume of waste deposited at landfill cell per day divided by the compaction and number of leaf daily. So in this case, we are assuming that the waste is being compacted to 0.25 meter horizontally, and there are three times of leaf daily. So substituting all the value inside the equation, we finally find that the area needed to accept and bury the waste is 0.981 meter square. Meanwhile, the area needed per year can be calculated by multiplying the area needed daily with 365 days. So, the area that is needed to accept and bury the waste per year is 358.065 meters square per year. Lastly, the percentage of disposal is being calculated using the equation waste disposed in landfill divided by the total waste generated, and then is being converted to percentage by multiplying 100%. So the percentage of disposal is 24.7%. This means that 24.7% of the waste from this residential area is being disposed at the landfill.